Let's take a look at this example. In this problem, we have first term expressed as a standard SOP, and rest of the terms are not standard SOP terms. Why? Because if this one has 4 variables, this one's supposed to have also 4. This one has to have 4, 4, and 4. They do not have them. That's why we have to expand these terms later on. Now, let's concentrate at the first one. Remember, anytime we have negation bar above the variable, that variable represents 0. So I'm going to have over here 0, 0, 0, 0, means this term represents 1 in cell 0. Let's take a look at the next one. I have A, B naught, D naught. I'm missing C. Keep in mind that one variable represents 2 combinations, 0 or 1. Because I'm missing one variable over here, means I'm missing 2 numbers. So keep in mind A is going to represent 1. Why 1? Because there is no negation bar. B naught represents 0. That's why I'm going to write 0. And D naught also represents 0 because I have negation bar. 0, 0. And C could be 0 or 1. Remember, I create 2 numbers because I'm missing only one variable. One variable represents 2 combinations, 0 and 1. That's why I can create only 2 numbers. This is binary 8 and this is binary 10. Binary 8 and binary 10. I'm finished with this term. Let's take a look at this one. I have missing A and I have B, C naught, D. Remember, anytime you're missing one variable means I'm going to create 2 numbers. I'm going to make 2 numbers. B represents 1. C naught represents 0 because negation bar. D represents 1. A could be 0 or could be 1. This is binary 5. This is binary 13. I'm finished with this one. Let's take a look at this one. I have A, B, C. A, B, C. I'm missing D. A represents 1. B represents 1. C represents 1. D could be 0 or could be 1. This is binary 14 and binary 15. 14 and 15. I'm finished with this term. Let's take a look at this one. I have A naught, B, C. I'm missing D. A naught represents 0. 0, 0. B represents 1. C represents 1. D could be 0 or could be 1. This is binary 6. And this is binary 7. We've finished mapping this expression. Next, let's take a look how many groups we can create over here. We have one group. I'm going to start from the biggest one, the group of these 4 ones, and I can create another group of 4 ones, 1, 2, 3, 4. I can create group of 2 like this, and I can create the group of 2 like this. This is my map with groups. Let's continue. This time we are going to look at our groups and try to simplify our expression. I'm going to look at the group which has ones in cell 0 and cell 8 first. So this group is placed in one column and two rows. The common variable for these two rows is B naught. That's why I'm going to write over here B naught. This group is placed in one column. At the top of this column we have C naught, D naught. I'm finished with this group. Let me talk about this group right now. This group is placed in one row and two columns. Anytime I have group placed in one row, I simply copy down everything, whatever is at the side of that particular row. In this case, I have A, B naught. At the top of these two columns, I have D naught. D naught is the common variable for these two columns. D naught. I'm finished with this group. Next, let me talk about this one. This group is placed in two rows and two columns. The common variable for these two rows is B, and the common variable for these two columns is D. I'm finished with this group. This group is placed in two rows and two columns. The common variable for these two rows is B, and the common variable for these two columns is C. Now let's take a look if we can factorize something or use exclusive or exclusive NORs, or maybe we can use De Morgan theorem in order to make this expression a little bit shorter. So let's take a look at this expression. We have B naught and I have C naught, D naught. I'm going to factorize B from these two terms. I have plus B and I have D or C, or A, B naught, D naught. Now, I can use De Morgan's theorem and say that this is B naught and I have C nor D. Or I have B, I can change the order of these two variables and I can say this is C or D. Copy down whatever I didn't use. I have A, B naught, D naught. Because these are the complements, I'm going to call this Q naught and I'm going to call this one Q. I have B naught, Q naught, or BQ, and I have A, B naught, D naught. This is exclusive NOR. That's why I'm going to write this as B exclusive NOR with Q or A, B naught, D naught. Where Q, we said, is nothing else, just OR gate, and I have B exclusive NOR C or D, or A, B naught, D naught. This is the simplest expression which I can find. So now if you want to implement it, so I have B exclusively NOT with OR with inputs C, D, and everything has to be ORed to the 3-input AND gate with the inputs A, and I have inverters, input B and input D. Everything is supposed to be ORed together. So these are the solutions to my problem.